All right, we're going to go over a couple questions from the Chapter 11 pretest. This is number 7. 3 root 2 times 5 root 3 over 5 root 4 times 2 root 8. First of all, that glares at you and says, please, please, please simplify me. Root of 4 is equal to 2, so we simplified it right away. On the top, we just multiplied it out. There's nothing to simplify. Root 2 or root 3 don't simplify. 3 times 5 is 15. Root 2 times root 3 is equal to root 6. 15 root 6 on the top. On the bottom, this becomes 5 times 2, as we wrote down here. This is 2 root 8, but root 8 simplifies. Yeah, it doesn't glare at you and say, come on, it's a perfect square, but it does say, break me down, and let's find a perfect square inside of you, and it does. Root 8 equals root 4 root 2, so we write it down. We've got 2 as we had there, and root 4 root 2. We're going to get this simplified now. This equals 15 root 6 on the top, so it's equal to 15 root 6 over, now what's 5 times 2 times 2? 20. And that's 20 times 2 now, because this root 4 is equal to 2, root 2. We're almost there. We're going to simplify that even more. The obvious thing is 20 times 2 is 40, so it's 15 root 6 over 40 root 2. Now what do we do? Are we done?
No, you have to.
Not quite. Yeah, we can, but we can't just divide them directly. We could do this, though. We could write 15 root 3 root 2 over 40 root 2 and cancel the root 2's, because root 2 over root 2 is equal to 1. All right? And now the root 2 over root 2 is equal to 1. We're left with 15 root 3 over 40. And then it's 15 over 40. There's one thing we can do there. We can divide top and bottom by what, Jessica? Top and bottom can be... Just move aside.
Oh, sorry.
Divide by 5. So the top is 3 root 3 and the bottom is 8. So 3 root 3 over 8. When we divide by 5 on top and bottom,
because
right?
5 goes into 15.
Okay, just a second. Over 8. Okay? Because we divide by 5.
If it's 8, it's 8. Isn't that just 1?
We divide it by 5.
So then,
yeah. 3 root 3 isn't just 1?
3, no, root 3 over root 3 is equal to 1. 3 root 3 is 3 root 3. You know, when we have like root 2 divided by root 2, anything divided by itself is equal to 1. Okay? So 3 root 3 over 8.
Okay.
That's that one. Anybody have any questions? I know we went quickly, but you know, we've done this one before, so you got to pay attention and do it. You have to write this down. Okay? No, it's not that. This one is number 5. The root of 12z squared v over the root of 4zv. What's the first thing that we can see to do? Factor it out. Yep, that's right. We simplify it, break it down. So it's root 4 root 3, root z squared, and root v on the top. Root 4 root 3 root z squared root v on the top. On the bottom, what about the bottom? What's root 4 equal to, Jesse?
2.
2. So it's 2 root z root v, or 2 root zv. Yeah. Oh, sorry. Were you able to find those?
Yeah, I just have to make it.
So here, you just cross those out.
There you go. See when we break it down, just move aside a little bit so people can see. When you break things down, it just makes it so much easier. Because you see things clearly. When you have the same thing on the top and the bottom, you can cross them out because it's equal to 1. 1 over 1. We've got, on the top, we've got our perfect squares. What's the square root of 4? 2. So it's 2 root 3. What's the square root of z squared? Z. So it's 2z root 3 on the top over 2 root z. Now what do we see that's the same? Top and bottom.
Z.
No, because this is z over root z. The 2's cancel. So we're left with z root 3 over root z. And it's really easy.
Really unnecessarily complicated.
Not really.
Like it is, though. Like why?
Yeah, well, that's another question. At this stage in the year,
Okay.
There it is, folks. Any questions?
It's not gonna.
Okay, we're not finished. We better take that box off. Because why? Why is it not finished?
Z's cancel.
No, they don't. The z and the root z don't cancel. You can't have a root in the denominator. Why not, Kiara? What do we do to that root? We're not allowed to have roots in the denominator.
You multiply.
Yes?
Multiply.
Multiply by itself. But if you do it on the bottom, you also have to do it on the top. So you multiply by root z over root z. Better do it in different color ink. Because otherwise people will wonder why. Here's green ink. Or red, that's fine. Root z over root z. Okay? There you go. This is called, does anybody remember what this is called? Rationalizing the denominator. Good job. You remembered pretty much. That's just what it's called, okay? You multiply by...
Jesse, for just a second.
Jesse, come on out.
So then the answer would be.
You're the next contestant.
I'm guessing 3z.
Yeah, z root 3z, good, over z. Put it in the green box.
What do you multiply by?
You multiply by root z on the top and bottom because, well, the reason you multiply by root z on the bottom is because it simplifies it. Because the root of anything times itself is just that sig. Root z times root z is z. Remember we did that? Root of 100 times root of 100? 100. Root of 1,000 times the root of 1,000?
1,000.
Root of a million times the root of a million?
Million.
Root zxy is times root zxy is just right. Remember that? That's a key thing we had to learn. And so what we do is we multiply by root z because it simplifies the bottom, and then we have to, by the laws of mathematics, if you can't just pull things out of the air. If you multiply the bottom by root z, you've got to multiply the top by root z because that's 1. Root z over root z is 1.
So today, would you not cancel out the z's?
No, there. Oh yeah, the z's can cancel.
What part do you
Yes.
understand?
Hey, Glenna,
Yeah.
we can cancel out the z's now.
Oh.
So again, we're not done.
Period.
Okay. So we're just going to have root 3z, and that's it. That's our
So
final
that's
answer,
3z.
right
I
there.
still don't understand though, why would you bring that out? Like, how would you know?
Bring one
What do you
out.
mean?
How would you know to do the z's?
Because
can't have
it's always the lower number. I mean the denominator.
What?
The denominator, you multiply it by the denominator when it's a square. When it's a
Why?
root.
To get rid of the
To get rid of the
You're right
square.
there,
have
Sean,
the
you're
square
right.
and the
To
get rid of the square root symbol.
Okay, I'm getting like 3 different answers. at
No,
one time.
because you want to get rid of the square root on the bottom, right? You don't want to have a square root sign on the bottom of a fraction.
It's not on the bottom.
Well, it was. The root z is in the bottom of the fraction, okay? Yeah? So you
That's
see,
z square
right?
3z over z,
Square times the square is 1, or rather, z itself.
which equals 3z. Square root 3z.
Yeah.
Do you get it now, Jessica?
Do you? No. Okay, here's the deal. I just wrote that up over here.
When you have when you
If I was doing it by myself, I would know to do that.
wait, listen. When you have a fraction and the denominator is a root, square root, you can't have that. So in order to get rid of it, you're gonna multiply both top and bottom by the denominator to get just a regular
Yeah.
number or letter.
The key is that you can't leave your answer with a square root in it. So what do? Well, you look at what that is. If that were root xz or root xyz, then you would multiply by what?
Root x, y, z.
Exactly. And whatever you multiply by on the bottom, you have to multiply on the top to make it 1. So that's really your answer. That you have to multiply by whatever it is. Because whatever it is times itself is going to nullify the root sign.
Then keep going.
Because of that thing we said, root 1,000 times root 1,000 is 1,000. Root xyz times root xyz is xyz. So to finish this one off, continue on this one. So after you've done that, root z times root z is z. So you got z in the bottom. On the top you have z root 3 times root z. Well, when you combine that, that's z root 3z. That's what we have here. So now we're up here. Z root 3z over z. The z's cancel. It's 1 over 1. And so our answer is root 3z, and we're simplified. That's all you're doing in these questions is simplifying. You're making it as simple as you can. We took something very complicated looking, a fraction with different types of radicals in it, and we were able to simplify it down to this nice little root 3z. Okay? That's the object of the game.